Привет, меня зовут Daniel, и как ты можешь слышал, я очень плохо говорю по-русски, потому что я из Колумбии. То я машина общения группы лидер в моей университет, я бегал 3 раз компетенции мой программист проект в моей университет, я был спикером в Novo Hamburg университет, это университет в Бразилии стране, а я тоже сделал эту конференцию в мой город. Я буду говорить по-английски, потому что я очень плохо говорю по-русски. So, what I did? This is a programming language. It's not a real programming language. It's a Lisp dialect. You can program this in German and Russian, and you can think it will be a problem to code in Russian because Russian have a special alphabet, Cyrillic alphabet, and in Russian you have umlaut characters. That is not a real problem in Python 3. In Python 2, you're going to have a problem with that. In Python 3, you can create variables, strings, with any problem. What are my motivations for do this programming language? I was learning Russian and German. I have a German and Russian family. Why not to make a programming language? There is a challenge that if you make a programming language, operating system, and a navigator, you're going to be a great programmer. So I talk a lot of times about Lisp, but what is Lisp? Lisp is not a real programming language, it's a meta-programming language. This means it's a template for generate other programming language. It's a kind of hack for make it. It was launched 64 years ago by John McCarthy in the MIT University, and the acronym of Lisp means Lisp processing. There is a lot of Lisp dialects, and during the time, the years, the people do that, and born Common Lisp. Common Lisp is a standardized Lisp dialect because a lot of different programming languages, they try to unify that. Later born Scheme is a simplified Common Lisp. We have Clojure, that is another Lisp dialect. It is on the Java virtual machine, and it handles very good concurrence and parallelism. And there is Emacs Lisp. Emacs Lisp is another this dialect created by Richard Stallman. I think you know who is. And you use that in the Emacs text editor. So you see some examples of this programming language. Is strange, is not useful, but it's a good way to understand how to make a programming language. The process to build a programming language is a hard process, but here is a simplified version. This is not an esoteric programming language. I don't know if you know the esoteric programming language. This is how know BrainFuck. Okay, BrainFuck is a kind of esoteric programming language. It can do everything, but it's not like this. This is more powerful because it has several structures like control structure, functions, and more. You can see here we have the if. We can create functions. That is the function for that formula. We can mix natural languages. See we have if in Russian and the other text in not Russian. We have to know everything is inside parentheses because parentheses means it's a list. The first element of the list is the name of the function, and the other elements are the argument for that function. This is not a pure functional programming language because it don't have implemented monads. You know what is monads? Who knows? Okay, this is a structure for handle side effects. We have a lot of side effects, and it's not pure. The pure functional programming language handle side effects is not going to have a memory errors. It's going to handle very good input and output. But here we don't handle it. It's not complicated. Sorry, I mean compilated. And disable is the process that you need to make all programming languages. You're going to start with lexical analysis. The lexical analysis, also known as tokenizing. Next, you're going to pass to parsing, also known as syntax analysis. Later, semantic analysis. Later, optimization. And next, code generation. We don't going to see code generation here. And we're going to talk more about the rel and the val function, not the Python val function. I take most of the comments from that repository, Kanaka mal. Mal means make a Lisp. There is more than 50 implementation of Lisp dialect in more than 50 programming languages. So, what is a relp? Relp is a readable print loop. When you type Python in the terminal, you are accessing to the Python relp. It's the entry point for the programming language, and there you can test if the programming language is working correctly or not. Next, we have the val function. It's not the Python val function, and here we convert from the Lisp syntax to the Python syntax. It's a function that processes the Lisp code and structured Lisp, treating them as a directly available syntax and interpreting constructions, dynamical, supporting macros, and conditional with an explicit abstract syntax tree. In the second line, we take the first element from the list, and in the last line, we do the calculation of that function, passing all the arguments there. But we need to structure the information better to pass to the val function, and everything going to have a meaning before doing the val function. We need to start with the lexical analysis or with the tokenizing. It's the process for separate the information in substrings called tokens. You can see there is an example without tokenizing, and there is another example without tokenizing. We do that with a regular expression because it's a powerful tool that have a certain predictive power. It can know very faster if it's going to work or not. Next, we have syntax analysis. Is the process to verify that our grammar is being followed, but here we don't make a syntax tree. In other programming languages, you need to build an abstract syntax tree, but here not, because our grammar is special. We have a special grammar called S-expression. That grammar allows us to transfer the tree with the eval function while we are doing the recursion. The recursion make a tree. And what is a grammar? Grammar is a set of rules that let us how we can combine the tokens. The only thing that matters here is the production rules. The production rules, there we define how we can combine the tokens. We have the terminal symbols and non-terminal symbols. In our grammar, the terminal symbols are the atoms. The atoms are integer, floats, strings, variables, functions, and the non-terminal symbols are the list. If you have a function with 10 elements, that is not just a list, one list. There is more than that. I mean, the lists are nested. If you have 10 elements in a list, you have 9 elements, one instead in each other. This expression expresses your program and manipulate it in the same way and the interpreter would. This lets you add your own language feature without modifying the compiler or interpreter. Okay, we have everything working, tokens, we have the information structured, we pass this to the semantic analysis. You see there, right now the interpreter knows what is what. I mean, the letter no is a separate word, the quadrant is an atom, what is a function, and when you concatenate an integer with a string, the error will be returned by the semantic analysis, and it's the process to give the meaning to all tokens. Okay, but how we know if a atom is a number, is a function, or a variable? If it's a number, you need to pass it for a regular expression, because the regular expression can check if have the pattern to be an integer. The regular expression is a tool that lets you define patterns and check it later with Boolean expressions. We have here float regular expression, string regular expressions, and in the image you can see there is a automata because the regular expressions generate an automata internally for a number. That is example. With that, we have seen types. In Lisp dialect, we don't have symbol tables. The symbol tables are a matrix when we save the data of the variables and the variables. For example, the value, the name, the type. But here we have a dictionary. The dictionary data structure is very powerful because it's the in O1 complexity to insert, delete, and set item. And we can make a personalized programming language with this. You can change in runtime the predefined functions and more. And now, our example of Quadrat, the function that we are talking before, is now in the environment. Someone asked me, hey, I can make a programming language that can be programmed in all languages. I don't like Portuguese, Spanish, French, Russian, Chinese, German, and other languages. Yes, you can. You have two ways to do this. One is saving all the reserved words in the environment, save it as the key of the environment. And the second one is add a translation before access to the environment, to the dictionary. And the environment going to be in English, everything in English, because the English is a interlingual, is a intermediate language for the translator. Okay. Who know what is a macro? Okay. The people say, here in Lisp there is all macros, but it's not true. The most of things are macros because it's like copy-paste where we are in the abstract syntax tree, when we are in the code, to their parts. The macros is like a function, but it not do calculations during the compile time. It just copy and paste the code. We have a comparison between macros and function. The function are completely late. I mean, is executed during the running time. The macro is not. The type checking in a macro is not because you copy the value and insert when it's called the macro. In the function, you need to do that verification. Macros increase the code length. When you're going to compile a Lisp dialect, you're going to see it have a lot of line of codes. You need a lot of times, and you need a lot of storage because it's replicate the code, and replicate the code because it uses a lot of macros. Okay, how we can make the functions and variables here. To make the variables is very simple. Add the word to the environment, and you're going to have a variable. Later you can call it and use it, very simple. And the function is use the part of code in the environment and associate it with the name of the function. We have control structure here. It's very simple to implement. We just call the Python if and interpret it from the root. But while, where is the while? We don't have while here because this is a functional programming language. We need to learn how to make a fast recursion, and I am a terrible person because I commented here. Who like to use recursion? Okay, just a person. I don't like, personally, I don't like to use recursion, but I have to learn it. Finally, we have a programming language. We're going to test it. I'm going to pass this function. It's a functional for factorial with the argument 34. And we're going to have an error. We're going to have a stack overflow because the recursion is fill the stack. Someone say me, hey, increase the recursion limit to a very high number on infinite. And I say, no, that is not the real solution because it's going to give you another time and another time stack overflow. There is a real solution for that. That is tail call optimization. There is a way to handle a recursion as a for or a while. This is used in programming language like Haskell and other ones. It avoids the unnecessary stack manipulation operation, the stack overflow, and improve performance. It is used in that programming language and other ones, and we have a problem. Python don't have TCO native. It have a tool that helps you to do this, but it's not native Another programming language don't have this native because it led to bugs. It's going to cause you bugs when you do recursion. We have a way to optimize the code, not all times using recursion. Sometimes we add a while because sometimes it's going to go with the while, not going to do unnecessary recursion cycle. There is in Python something called trampolines, and it's a way how we can use tail call optimization, wrapping functions calls in special objects with that decorator. Another option is use other programming language, connecting Python with other programming language, who connect Python with other programming languages. This is good because we know Python consumes a lot of energy, sometimes it's slowly, and use with other ones is lent to be more fastest code naturally. We have PyU3 for connect with ROS. I tried this with ROS, optimizing this programming language, but not was a good solution because the community of ROS tried to make a TCO to use it in the programming language, but they decided, no, we're going to make a cargo package for that. And when I was doing this, the cargo package not was very good to documentate, and I can't use that. I archived that with C types. This is abiding between C and Python, and it helped me to create the TCO in C with Python. We have extra features here. We have try-catch structure, and we need the comments for the code. In this code, because it's all inside parentheses, we need to use a kind of a special comment that is called quote. It's going to deactivate the evaluation of the code. I mean, if you eval, we define the variable j to 98772, and we made quote jota, it's going to return jota. If you do that of an expression, it's going to return you the expression. The common problems, it can merge very easy with the properties of your programming language. You need to separate the programming language. When you are making this to your language, programming language, I mean, I am making the room, it can merge very easy with Python and need to isolate this. A good way for do this is with object-oriented paradigm. Okay, we have the programming language. Is the end. The conclusion, this is not a industrial tool, this is not a professional tool, it's a good way to explain how you can make a programming language. Questions?
Okay, thank you very much. Can I borrow this? I just want to get back to one slide, and yeah, I think you guys liked it, right? Вам это понравилось, не так ли? Ледь. Это так мило, напомнило котика из мема, который говорит «нет». Да? We have a meme with a cat who says «no, нет». And here you have a ледь, which is very, very cute. Окей. Так, друзья, вы можете задавать вопрос на английском, можете на русском, только если не очень сложный вопрос, я буду переводить. Вот там уже есть микрофончик, а Миша, ты следующий.
Thanks for your speech. And one simple question. If I want to use your language, what should I do? I just download a Python package, install it, and just import it, everything just good to go. Or do I need to do something additional, like how do I use it if I want to try it out?
You are crazy.
First of all.
Yeah, obviously.
You go to that repository and git clone and execute the main file. That's all.
But it's a Python file, so it just...
It just run Python main.p. That's very simple. You don't need to download anything.
Thanks.
Окей. Я сейчас тебе дам, Миша. Давай.
Can you speak German?
Ich spreche nicht sehr gut Deutsch und ein bisschen.
Okay, danke sehr. Es war sehr angenehm, diese Vorlesung zu hören. Super schön, wunderschön. Ich habe vielleicht zwei Fragen. Also,
Entschuldigung, ich nicht verstehe Deutsch sehr gut.
Очень multilingual meetup у нас получается.
Okay, thank you for your Vorlesung. Now I have a mixture of German and English. What was your goal? Was it to find connection with your roots, with German and Russian roots, or just to have fun? Was it some pet project? And the second question, why have you used Python instead of plain Lisp? I think it was easier to use Lisp, to write Lisp, no?
I'm going to start with the second question. Yes, it is better to make this in Haskell or Lisp, programming language that have a native TCO, but I use Lisp because I use Python. I start with this because I planned to make speaking of in the Python meeting in my city with another topic. They don't think this is not interesting, and I say, hey, I can make a programming language, why not in Python? It's not the best, but it's a good way to understand how to make that. My motivations for this is connect with my roots, learn a little bit of the language, and do a challenge. You know, to be a good programmer, you need to make a programming language, operating system, and a browser. And this is a good way for a start.
Yeah, very, very good. By the way, we had a pre-run call with Daniel, and I looked at the presentation, but only now I realized that Deru, what is Deru? It's like Deutsch and Russian, right? Deru. But in Russian, we also have the word Deru. Deru. You look it up. Okay. Yeah.
I want to ask a question. Why did you choose these two languages? And are you gonna add some more languages, or just that's all?
Maybe in the future, I'm going to make a programming language for all natural languages with Clojure. I chose German and Russian because I was learning it and my roots.
Yeah, it's family issues, family reasons.
Okay, got it.
Okay, давай, Матвей.
One. Okay. Do you think about make a tutorial from your presentation? And I think this is people will be use it.
Yeah.
Very difficult question. I think I have to improve this a lot. Maybe do it again with Clojure, but maybe yes.
Yeah, good. Вот там предпоследним, что, уже я сам, да? С двух концов побежали. Молодцы. Да.
Thank you for your speech, and I have two questions. First, why have you chosen Lisp syntax over all other syntaxes, like basic syntax, like Pascal syntax? Why Lisp?
Make a programming language is very difficult. As I said in the start of the speaking, Lisp is a meta-programming languages. And this is like a kind of hack to achieve meta-programming languages and not doing esoterical programming languages.
Okay, and the second question is, what about error messages? Like, are they in English, German, Russian, or maybe there is a way I can write a translation for my favorite language, like, oh, you can't add integers and strings, you can't do this. Like error messages, are they in English or some other language?
In English.
Okay.
And there is no way to...
Is there a way to make it multilingual?
Yes, it's a way.
Okay, so it's going to be implemented in later versions of Deru.
Okay, thank you.
Okay.
Hello, and thank you very much for the presentation. Dovrei parlare inglese. Sì? Gracias. Thank you very much for the presentation, much appreciated. The question is, in your opinion, how do you think will be as such a programming, well, functional programming language is popular for like about in a decade, so maybe 50 years? In your opinion, how do you think will it be popular?
Difficult question. I think there is a tendency to use the functional programming languages because it is another way to thinking about programming. In good universities, I know they have special courses with functional programming languages, and I don't see it very far. I see it more closer today, but in some places, special places.
Thank you very much.
Thank you. Так, по вопросам у нас вроде бы все. I have a last question. How old are you, by the way?
Guess my age.
Guess. So how old?
33. 23.
23. So, yeah, the guy is 23. Человеку 23 года. Он приехал в далекую заснеженную страну, в темную, сделать доклад на митапе. Вот. Я считаю, это достойно еще бурных аплодисментов. А еще, мне нравится, что это this is showing how Python community in the world is developed and how we connect with each other, and I'm very happy that we have such opportunity. Please, someone make a photo. So yeah, Russia and Colombia, friends for life, and yeah, we will have a task.
Okay.
Yeah.
For the first question.
Make a friend and lots of enemies.
Yeah.
I am joking, of course.
The first question.
No, the first. Oh, this. Давай. How you say it? Felicitación.
Felicitaciones.
Felicitaciones. Okay, very nice. Спасибо тебе большое за то, что закрыл этот год выступлений, митапов Moscow Python. Да, были рады видеть, очень приятно.
Очень приятно будет здесь. Большое спасибо за все.
Супер.